Okay, so let us start our class. Very good morning to you all. So in the previous class, we were trying to solve some kind of a problems on the slope stability. So let us continue the same tutorial on the slope stability. So I request everyone to note down this sum. So this again pertinent to analysis of infinite slope, but for three different conditions as shown here. The first condition is when the soil is dry. The second condition is when water seeps parallel to the surface of the slope, and the third condition is when the slope is submerged. So in all these conditions, you are asked to determine the height of the slope or the permissible height of the slope. So first of all,
What is the example 10.3, sir? I mean, the
point
previous example.
maybe the previous example. So not exactly idea. I-20. Okay, we will see. They have given some kind of a data. Analyze the slope of example 10.3 if it is made of clay having C dash 30 kilopascals and pi dash 20. E is 0.65 and GS is 2.7. And under the following conditions, when the soil is dry, when the water seeps parallel to the surface of the slope, and when the slope is submerged. Okay. In all these three conditions, you are requested to determine the height of the slope. So let me show the first one. If you look at the sum carefully, there is no direct values of the density. Here, if you look at the condition of the slope, it is available in dry form, saturated form, and
Sir,
submerged form. Yep.
sir, we will consider factor of safety equal to 1.
No need, no need. I will just tell you how to do it. Wait for a minute. Okay. So when the slope is dry, what would be the height of the slope for this given data when C dash is 30 kilopascal and pi dash is 20 degree? But to calculate the density values, it has been provided the wide ratio E of 0.65 and GS of 2.7. So we can able to calculate based on the given wide ratio and the specific gravity value, the dry density or the saturated density. So as you know from the volume mass relationship of the soil mechanics, so gamma D is equals to G into gamma W by 1 plus G. So as G has been given as 2.7, gamma W is 9.81 in terms of the kilonewton per cubic meter. Wide ratio is 0.65. So if you substitute everything into this equation, you can directly able to calculate the value of gamma D. On the other hand, suppose when the slope is in a saturated condition or seepage condition, let us talk about the seepage condition. So when the seepage is parallel to the surface, that typically prevails the saturated condition, but not the submerged condition. So therefore, gamma sat is equals to, so G plus E into gamma W by 1 plus E. So I don't need to recall these equations. Everyone very well aware of. And once I know the gamma sat, gamma D, then from the known value of the gamma sat, I can able to determine the submerged. That is gamma B. Gamma B is equal to gamma sat minus gamma W. So 19.9 minus 9.81. So then what you will get is 10.09 kilonewton per cubic meter. So this is how you need to calculate. So the density values for different soil conditions, say dry or saturated or submerged. So then try to recall the very first condition is when the slope is in dry state. So for a dry soil, the stability number Ns is given as C dash by gamma D into Hc. So in fact, if you recall, the generalized formula is C dash by gamma into Hc is equals to cos square beta into tan beta minus tan pi. So here, assuming that the factor of safety with respect to the friction is unity. Friction is unity. However, in the generalized formula, gamma will be taken as a gamma, but in our case, the soil is in a dry state, so therefore gamma will be replaced with the gamma d. Now C dash is given. The height of the slope you need to determine. Beta, that is the slope angle. So here the slope angle is 25, which is also given, and pi, the angle of internal friction, that is 20. So everything has been given. So the only unknown is the HC, that is height of the slope. So substitute all the formulas, so all the parameters into this equation. So then try to calculate what would be the critical height of the slope, that is HC. So that is HC is equals to C dash by gamma d into here. The original formula is C dash by gamma d into HC is equal to cos square beta into tan beta minus tan pi dash. But one of the parameters can be taken as the stability number Ns. So here cos square beta into tan beta minus tan pi has been taken as the stability number Ns. So therefore, so it is equated such that C dash by gamma d into HC is equals to Ns, that is the stability number. So as there is no other scope to determine the stability number Ns, so it is easiest way. Or the other way around of understanding this one is, so we have equated cos square beta into tan beta minus tan pi to the stability number Ns. That's it. So once this is known, substitute in this equation. So then calculate the critical height. Okay. So this is simple and straightforward. This is the case number 1. Now case number 2, when the water seeps parallel to the surface of the slope. So this is the equation again. In fact, if you look at the other formulas, there is another way of calculating this one also. Just look into it. The same equation has been used. However, so earlier gamma we have taken as a gamma d because the slope is in a dry state. But now when there is a seepage, so the soil is in a saturated state. It is not in a submerged state. It is in a saturated state. So therefore gamma is replaced with the gamma sat. So we have discussed about how to determine the gamma sat. Now only unknown parameter is the critical, that is HC. So take gamma as gamma t and substitute in this equation. So then what you get is the height of the slope, that is 6.51 meter. Now additionally, when a seepage is parallel to the surface, additional parameter that comes are attached to the second term is gamma dash by gamma sat. Here you can see gamma dash by gamma sat. Gamma. Either you can take the previous derived equation as it is, or you can use this equation. This is simplification of the same previous derived equation. No need to bother. Okay. So now if you compare the previous case, case 1 with case 2, you could see the major changes. The first change is gamma is replaced with the gamma sat, and gamma dash by, that is gamma submerged by gamma sat, is multiplied with the tan pi. So these are the two changes. So then what you get is 6.51 meter height of the critical height of the slope. The third case for the submerged slope, same equation, HC is equal to C dash by gamma. Here since it is a submerged condition, so your gamma will be replaced with the gamma submerged. Gamma submerged. So submerged, substitute submerged, then what you get is the height, critical height of the slope as 35.4 meter. Okay, so this is the solution to your problem. Now, having understood how to calculate the critical height of the slope for different soil conditions, now let us re-look into what would be the critical height of the slope. So for example, if you take the dry condition, the critical height is 22.25 meter. While if the seepage exists parallel to the slope, the critical height is drastically reduced to 6.51 meter. But when you maintain the submerged condition, the height can be increased to 35.4 meter. 35.4 meter. So that is a 22.5 meter when it is a dry condition, and 6.51 meter submerged seepage parallel to the surface and 35. Now my simple question is, why the height requirement is high in case of the submerged condition as compared with the dry condition? Anyone could able to throw some light?
Sir, can you please repeat?
See, we have calculated 3 critical heights of the slope for 3 conditions. Now submerged condition has yielded the highest possible height of the slope, that is 35.4 meter, and seepage parallel to the slope has yield least slope height, that is 6.51 meter. But if you compare the dry condition with the submerged condition, you may presume that normally the dry condition should make it possible to go for the highest slope, but rather it is the submerged condition which is allowing to go for the highest slope value. Why?
Sir, due to unit weight, sir.
Due to unit weight. That
Like,
is,
sir, for the submerged condition, we have a gamma days, sir, and which is lesser than the gamma d, sir. That's why we can see by mathematically denominator term is very low compared to dry condition, sir.
okay,
That's why
so
it gives
yeah,
35.
this is a interpretation that we can able to make from the analytical equation. But others, I request try to understand the physics of this one. Okay, so mathematically we understood, because gamma submerged is less than gamma value, so therefore height is increasing. But what is the
And
mechanism?
sir, according to me, sir, for the submerged condition, sir, all the load is carried by the soil itself, sir. Means soil interactions taking place. That's why they are allowing more height compared to dry conditions, sir.
But where the soil interaction is taking place?
Sir, in the submerged condition, we are taking the gamma days, which means, sir, all loads is means soil interaction means pore water pressure is zero, sir.
Okay, so any other logical explanation? Others? Whatever he is saying is to the some extent correct, but it should be more mechanistic way. You have to understand the other physics also. Suppose it, or Benish, or Savi, or Ashwant. Could anybody give the logical reason how the submerged condition is allowing the higher height than the dry condition?
Not sure, sir.
Not sure. Others? Okay. See, first let us take the dry condition. Say for example, this is the slope. Okay, so this is the rock interface and this is the slope. Now I'm also taking the another condition, that is submerged. So here, so this is the rock. Okay, submerged means the water level exists here. All right, this is the water level. Now in case of the dry condition, the gravity acts in the downward direction. Suppose if you draw the free body diagram or the component of the forces, you could see one force in the direction that is normal to the slope, another component is parallel to the slope. This is all right. So this is these forces are prevailing from the soil, but in case of the submerged condition, in addition to the forces prevailing from the soil, there is also one vertical component acting in the downward direction by the water component. Okay, so this downward component of the water to some extent counteracts some component, either in normal component or the tangential component of the gravity of the soil component. So because of this counteraction by the water, so we can go for higher height than the dry condition. Okay, so this is the reason why, so in the submerged condition we can go for higher height than the dry condition. So I repeat, so in case of the dry condition, there are only two components of the forces, which are normal and tangential to the sloping phase. While in case of the submerged condition, in addition to the normal and tangential components of the soil, there is an additional component, that is water component, which acts in the downward direction. However, this downward action of the water to some extent counteracts one of the components of the soil, either the tangential or the normal, and thereby it minimizes the weight. So for example, here if it is counteracting the normal component, so that means it is acting something like a buoyancy force. That means the weight of the soil, which is initially say x, will not be x, it is x minus something, x minus something. So because of that minus, we can go for the higher slope height. We can go for higher slope height. So this is the physics behind the allowance of more height in case of the submerged condition. So if you have any question, you are free to ask me now.
But sir, the downward force is the driving force, no, sir, usually. I mean, the weight when it is, we are seeing down driving force and the counteracting force. The weight is the driving force.
Okay, just imagine yourself. See, you are standing on an inclined slope. Okay, something is moving on the slope. When you stand, will it move or will it stop moving? Just imagine yourself.
I didn't get it, sir. Can you please repeat?
See, for example, you are standing on a sloping surface. Okay. Now, initially the slope is moving. Now, when you stand in the vertical direction, will the movement stops or will the movement accelerates?
It is stop. I mean 0.
That's what. So same the mechanism you can replicate here. So when you submerge the sloping condition, so this downward action of the water somehow prevents the movement of the soil or counteracts one of the components of this weight.
Okay.
Okay, or else just recall your soil nailing. So when you do the soil nailing, where you do it? Everyone, you have seen any kind of a soil nailing technique?
Yes, sir. We can also relate like this way. Means due to submerged conditions, sir, weight will be increases, which results in increase in normal stress, and finally increase the shear strength, sir. Strength, sir. Like S equal to
No,
C dash plus C.
they will not increase any kind of a strength. Don't relate it to strength because these are purely external mechanisms, some kind of overburden.
Yes, sir.
Okay, so this is like initially it was held by the weaker person, but now held by the stronger person. That's it. You can also recall your earthquake mechanism. See, for example, if you want to increase the damping, what you do? Or if you want to reduce the damping, what you do? You increase the mass of the body. Is it true? One of the simplest way of reducing the damping is increase the mass of the body. That is what is the whole crux of your earthquake engineering. Suppose if you do any design for the static condition and dynamic condition, if you are getting the column dimension of 1 feet by 1 feet under static condition, if you got dynamic condition, it will be 350 by 350. Okay, you increase the mass of the any element. So anyhow, so this is the logical reason. I hope.
Actually, sir, I meant to say, actually we are finding the tau f, na, sir, in every case. Actually, capital S is fixed, we know, sir, but tau f is changing, sir, for depending on the soil type, sir. So when submerged condition is there, sir, then tau f will be changed from dry condition, sir. and tau f in for the submerged condition is higher than dry condition, sir. So tau f divided by tau will be more, sir.
Okay. Okay, that's very good. If you can able to make such kind of a logic, very good. Okay, so now that's what about infinite slope.
So
Uh,
is this correct, sir?
uh, it is not exactly because see, whenever there is a moisture in the soil, it always try to reduce the shear strength component. Okay, if you say that logic, then more water in the soil means more should be the shear strength, but that is not true.
Okay,
One more
sir.
thing, sir.
Yeah,
In the first case, we are also using the C dash and phi dash,
yeah.
but it is dry condition, na sir. So shouldn't we be using the C and phi? I mean total stress parameters. Yeah.
See, total stress parameters means you have to understand one thing. Dry, you can use any parameters. In fact, there is a more prevalence of the total stress only under dry condition.
Yes, sir. I mean, in that case, the C and phi will be maybe higher, not will be. It may be higher, and then the NS value will not be constant, na sir, in the first and third case.
Uh, Maybe, but that's why I'm saying I'm not relating it to mathematical. Just try to understand the mechanism. Then once you
No, no,
understood
yeah,
the
that's okay. That's clear.
ah,
That's clear.
yeah,
The
yeah,
mechanism is clear. I'm just
ah,
saying that in this case, in particularly in the case of this sum,
ah,
we are also using C dash and phi dash in case of dry case.
dry
I mean,
condition. Yeah,
uh, that may not always be the case, na sir.
yeah. That is true. That is true. In fact, under submerged condition, you may not be taking the C dash and pi dash exactly. You have to take undrained condition.
Yes.
Yeah, that is true. That
Okay.
is true. Okay, so just note down the another sum. So this is on again a Taylor's stability number. How to use the Taylor chart, because this theoretically we have seen it, but we did not solve any kind of a problem. A cut slope is to be made in a soft saturated clay with its sides rising at an angle of 60 degree to the horizontal. So this is the figure given. So given undrained cohesion is 40 kilopascals and gamma is 17.5 kilonewton per cubic meter. Determine the maximum depth up to which the excavation can be carried out and find the radius r of the critical circle when the factor of safety is equals to 1, and find the distance b.
Yeah, you are not audible, sir. Hello.
No, but yes, sir, is not audible. Sir, you are not audible, sir.
Yes. Yeah, yeah. Hello. Am I?
Yes, sir.
I'm extremely sorry. I will repeat now. So this is the
Yes,
Taylor
sir.
stability chart that you need to use it for solving this problem. So if you look at this chart, this is a relationship between stability number m versus the slope angle beta for different values of beta and d. So again, d is a function of the height of the slope, that is h critical. This also we have seen. Now, as per the Taylor's theory, if beta is that slope angle is greater than 53, the failure is always toe circle failure. And if it is less than this one, either it could be slope failure or the toe failure or the base failure, whatever it is, depending upon the value of the d. So in our case, the beta has been given as 60, which is greater than 53. So therefore, we can conclude that the critical circle is a toe circle. The critical circle is a toe circle. So there was no question for any other thing to be discussed. Now, how to pick up the value of the stability number m, so that as you know, the value of the beta given is 60. So corresponding to the beta, so draw a vertical line, project onto the chart of the predefined curve. So from there, you draw another horizontal line onto the ordinate, which obviously yields the value of the stability number m. That is, so here in this case, it is 0.195. 0.195. Now from the stability number, so we know the relationship, the stability number m is equals to Cu by gamma into h. Cu by gamma into h. But you are asked to determine the critical height for a given value of the C and gamma. So the m stability number has been picked up from this chart. So now I know the value of the m, that is 0.195. So I only unknown parameter is h critical. So h critical is equal to Cu by gamma into m. So Cu is 40 kilopascal, gamma is 17.5, and the stability number m is 0.195, so 11.72 meter. Okay, so the critical height of the slope, when you want to maintain a beta, the slope angle of 60, that is the height you can able to maintain. Now the part B of this question is, what would be the radius? What would be the radius? Now here, in order to determine the radius, you need to draw some kind of the simplifications in the form of a triangles. Now if you look at the different triangles, especially triangle OAC, OAC, and we know OC and OA is nothing but the radius of the slip circle, radius of the slip circle, and AC is chord length, AC is chord length, while AC can also be written in the form of a arc length. If you take this as a function of the theta. Now, if you take the in the form of a triangles, the R is nothing but so DC, that is chord length divided by sine theta by 2. Or if you take the triangle OCD or OAD, your theta will become theta by 2. So sine theta by 2 is equal to opposite side by the hypotenuse. So hypotenuse is the radius r, the opposite side is the chord length CD. Chord length CD. So now we can relate further the chord length CD with the arc length AD, because we can able to determine the arc length but not the chord length. So therefore, this chord length DC is related to the AC, that is chord length, total chord length divided by 2, AC by 2. But AC in the form of another triangle, that is triangle ACF. If you take the triangle ACF, if I take the sine alpha is equal to the opposite side, that is H critical, by hypotenuse, that is the chord length AC. So sine alpha is equals to the H critical divided by AC. Now I need to rearrange in terms of AC. So AC is equals to H critical by sine alpha. So substitute these things in the previous equation and simplify. Then what you get, the critical radius R is equals to H critical divided by 2 sine alpha into sine theta by 2. So this is how we can able to derive the equation for determining the critical radius of the critical slip circle. I hope the derivation is clear to everyone. Now, but what is the value of the alpha and what is the value of the beta, and how to use these to determine the radius of the slip circle? For that, you need to use another predefined graph. So that is also proposed by the Taylor. So that is the relationship between alpha and theta versus beta, where alpha is angle made by the chord AC with respect to the horizontal, beta is the slope angle, and theta is the angle made by the failure plane. It's not failure plane, sorry. Theta is that acute angle between A and C of the critical slip circle. So now I know the beta. So I know the beta, that is 60 degree. So now draw an vertical line which cuts two defined lines corresponding to alpha and corresponding to theta. Now if I draw vertical line, so corresponding to beta of 60, it cuts the alpha predefined curve at some point, that is approximately 35. That means alpha is 35. Now the further extension of the same vertical line onto the theta curve, so I will get approximately theta of 72.5. So alpha is equal to 35 and theta is 72.5. So theta is 72.5. So now I know the alpha value, I know the theta value. So I know the equation R is equal to H critical divided by 2 sine alpha into sine theta by 2. So your alpha value is nothing but this one, that is 35, and your theta value is nothing but this one, so which is nothing but your 72.5. Now I know alpha value, theta value, H critical already we have calculated from the part A. So substitute everything, then what you get, R is equal to 17.28 meter. 17.28 meter. So part C. So I think you have been asked what is the part C? Find the distance BC. So this is the BC. So here simplification for BC has been given. BC is equals to nothing but E and F. So which can be written as AF minus AE. Because everything we have to simplify in the form of known parameters. So here known parameters are H critical, alpha and beta and theta. So convert everything into H critical and alpha and beta. So alpha is known, that is 35. H critical is known, 11.72. Then the theta, that is it's 72.5, not 75. So substitute here, then try to find it out the BC length, chord length BC, that is 9.97 meter. Maybe it may not be 9.97. There is something wrong. Alpha is 35, correct? But this is not 60. This is not 70, 75. It is 72.5 theta.
Sir, how do you find AE, sir?
How to find AE? You take the triangle of this one, na? ABE, because I know this this angle 60 slope angle, and I know BE. BE is nothing but H critical. So it's very simple.
Yes, sir.
Got it, Vishal? See, suppose if I take cot alpha, so which is nothing but, how do you define the cot? Base by opposite side, na? It is reverse of the tan. Tan is opposite by base.
Sir, not code.
Your voice is breaking in between. I don't know who is talking. Vishal or me?
Hello, sir. Hello.
Yeah, Vishal.
Sir, you will consider na ABE as a triangle to calculate AE. So
Yeah.
theta should be 60, sir.
Theta should be, that's what I'm saying, na? This 75 is wrong. This 60 is correct.
Okay, sir.
Okay. Or else it's very simple. Suppose if I take the triangle ACF, if I take cot alpha is equals to AF divided by the H critical. If I take the triangle of ABE, if I take cot 60 is equals to AE by H critical. In both the cases, H critical is the common. Okay, and I know the alpha, I know the 60. So replace AF with H critical. It is very simple. There is nothing great. Okay, anybody has any question? Any difficulty in understanding this sum? Okay, so can I go to next sum?
Yes, sir.
Yeah, so note down the...
This predefined graph will be provided, na?
Yeah, it will be provided in the exam. Okay, note down the another sum. A cut slope was excavated in a saturated clay. The slope made an angle of 40 degree with the horizontal. Slope failure occurred when the cut reached a depth of 6.1 meter. So previous soil exploration showed that a rock layer was located at a depth of 9.15 meter below the ground surface. Assuming an undrained condition and gamma sat is equal to 17.29 kilonewton per cubic meter, find the following. So determine the undrained cohesion of the clay and what was the nature of the critical circle, and with reference to the toe of the slope, at what distance did the surface of the sliding intersect the bottom of the excavation. So this is very good, another very good example. In the previous sum, we try to utilize or you try to understand how to use the Taylor stability chart, that is the relationship between stability number m versus slope angle beta. Now in this sum, an additional parameter has been given. So it is asked, so at what distance from the toe of the slope, so the slip circle exits. Okay, that is additional. Now first part A. So referring to the figure 15.13, so this is the same stability number. What has been given? So beta is 40. Now one thing you need to understand is when beta is less than 53, meaning thereby it could be toe failure or the slope failure. We do not know. And if you notice this figure 15.13, when beta is less than 53, there are several predefined graphs. So for different values of the d. So d is equals to infinity, 4, 2, 1.5, 1.2, 1. So that means the very first step is you need to determine what is the value of the d. How do you define the d? The d is defined as it is the depth of the soil layer up to the hard stratum divided by the height of the slope. So here the soil exploration showed that rock layer was located. So rock layer was located at a depth of 9.15 meter, whereas the height of the cut slope is 6.15 meter. So therefore D is equals to 9.15 divided by 6.1. So that is 1.5. Now pick up the trend line corresponding to 1.5. So here it is 1.5. Now corresponding to this graph, so you need to find it out the stability number value. Okay, now beta is 40. So beta is equals to 40. So beta as 40, draw a vertical line onto a trend line corresponding to D of 1.5. D of 1.5. So this is the 1.5 line. So wherever it is touching the 1.5 trend line, so from there draw another horizontal projection line onto the coordinate that would give you the stability number M. So here in this case it is 0.175. Okay, so now gamma sat has been given as 17.29. So therefore you know the stability number M is equals to Cu by gamma H. But you are asked to determine the undrained cohesion. That means the height of the slope is known, that is 6.1 meter. So only unknown is Cu. So Cu can be written as Cu is equals to gamma into H into M, where M is 0.175. So I now know all the parameters. So Cu is equal to H critical into gamma into M. H critical is 6.1 meter, that is already given. Gamma is 17.29, already given in the sum, and stability number M is 0.175, that we have determined based on the given slope angle beta 40 and D of 1.5. So Cu is equals to 18.46 kilonewton per square meter. So the minimum desirable undrained cohesion value of the slope to be stable is 18.46. Okay, so this is how the stability chart is used. Now the second question, that is part B, is what was the nature of the critical circle? So can anybody able to answer? It's just straightforward.
So it could be all types of failure, so like slope failure, base failure, and toe failure also, sir.
And toe failure. Okay. So the part, it is midpoint failure, that is slope failure basically. So here it is saying midpoint failure. Why it is midpoint failure? The reason is the partial answer is given in the sum itself. The answer is C. If you look at the part C, with reference to the toe of the slope, at what distance did the surface of the sliding intersects? That means it should be some kind of a base failure. So that they are terming it as midpoint circle failure or midpoint circle failure, the base failure.
Sir, if we mention all this failure, then you will this will be incorrect, sir.
No, it is not incorrect. But look at the sum carefully one to two times. So most likely the answer will be given in the sum itself. Okay, so there is another logic also. See, for example, in the previous sum, the hard surface directly lies at the toe level. But in this case, the hard rock strata exists at a more than 9 meter. So then you can presume that it could definitely be the slope failure. The chances for the toe failure are little less. Slope or toe failure is little less. Okay, so that's how you need to understand or you need to analyze the slope. Now the third part is.
Then it should be, sir, base failure, not slope failure, na, sir? Because
No, it's
slope
not a
failure
slope
is
failure.
passing.
No, it is a base failure.
So because hard layer is exists just below the toe, sir.
Correct.
And slope failure is passing the line, the plane, failure plane is passing through the slope, sir.
Correct. Okay. So now go to the part 3. Here d is equal to 1.5 that we have already calculated. Beta is 40 and n is 0.9. So here to determine the distance d from the toe, you need to use another predefined correlation, that is d versus slope angle beta. Now I know the slope angle, that is beta is equal to 40, and now I need to know what is the value of the n. So n is given as 0.9. So n is given as 0.9. But for 0.9 we don't have any predefined curve. So you need to interpolate between 0 and 1. 0 and 1. So corresponding to n is equal to 0.9. So try to interpolate. So and from there you try to draw another horizontal line onto the ordinate, which would give you the value of the d. So now the d can be equated as n into h critical. Oh, sorry, it is a reverse here. I know the d value, I know the beta value. I need to determine the n value. So corresponding to d of 1.5, draw an horizontal line. Corresponding to beta 40, draw an horizontal line. So both will meet at some point. This is the intersection. So if you look at this intersection, this is lying between 1 and 0. 1 and 0. So this is approximately 0.9. You can take approximate value. So now we know another relationship, that is distance d is equals to n into h critical. Now n has been picked up from the intersection. So h critical is 6.1. So 0.9 into 6.1. So it is 5.49 meter. So meaning thereby at a distance of 5.49 meter from the toe, so there is a probability of the critical slip circle can exit. So is it clear to everyone now? So I will tell you the original meaning of this one. So this is something like this. So this distance is 5.49. So this distance is 5.49. This is base failure. So the people have done simplification to so much extent. Only thing is you need to understand how to grab each and every parameter. Once you understand how to use these graphs, your life is quite easy. Okay, but only one thing is when you solve, so it seems to be like quite easy. But see, when you go for parametric variation, then you may find little difficulty, because in reality I do not know what is the height of the slope. So my first problem is what will be the critical height. Okay, so for that you need to do a lot of trial and errors, and it is also necessary to fix the value of the beta. So that is slope angle, corresponding to which the height is critical. So in a sense you also can able to draw a relationship between beta versus the critical height. With the function as a factor of safety. What is the minimum factor of safety value, corresponding to which you are getting the least factor of safety. So it may so happen that your critical height may increase, then followed by become constant, or may increase or decrease, or it may constantly decrease. Anything could happen. Okay, so once you understand this one, then you can pick up the critical height based on these trend lines. And other parameters also you can vary depending upon your interest. So for example, if my interest is my failure plane should not exit in somebody's boundary, then this graphs becomes very important. No, I have a sufficient distance, I don't bother about it. So my concern is only to go for maximum height of the slope. Then we can play with the other parameters. What should be the least angle of beta that I can go, so that my height is the maximum. Okay, so these are the few things that you need to think of. Okay. So again, please note down the another sum. So this is on C5 method. A slope with a beta is equal to 45 degree is to be constructed with a soil that has phi dash of 20 degree and C dash of 24 kilopascals. The unit weight of the compacted soil will be 18.9 kilonewton per cubic meter. Find the critical height of the slope. If the height of the slope is 10 meter, determine the factor of safety with respect to the strength. So here also you are going to use the stability chart, but that is different. So here we use another chart, that is the stability number versus the soil friction angle pi dash, and for different values of the beta. Okay, so now if you compare this graph, this Taylor stability number with the previous one, there was no scope for embedding the friction angle of the slope. That means it was purely valid for the cohesive soils. But now if you look at this graph, so this graph is valid for both C soil and pi soil, that is C5 soil. Okay, so far what we have discussed is valid only for the cohesive soils. Now let us enter into the C5 soils, how to determine the different parameters or how to use the Taylor stability chart for C5 soils.
Sir,
Yeah.
sir, I have doubt regarding to find the stability number, sir. Sir,
Just
like
ask.
when to use, sir, when to use the graph, when to use the analytical formula, sir. Like in previous sums, we have all the value like beta value and pi value. Then we use the formula like cos square beta 10 beta minus 10 phi. Here also it is mentioned beta value and phi value. Can't we
No,
use
you are getting
formula?
confused. You are getting confused. See, the very first question is belongs to the infinite slope, and the next question is belongs to the finite slope of C soil. Now this question is belongs to finite slope of C5 soil. Okay, Vishal, is it clear to now, Vishal? Okay, others also. The very first question which we have solved is belong to infinite slope. The second question that we have solved is finite slope but in cohesive soil. Now this slide shows the C5 soil, finite slope in C5 soil. Okay, so I think time is over. I will stop it here. Hopefully you have noted down. This chart is available in any of the soil mechanics book. Once you have noted down the sum, so try to solve by yourself. It's very simple. Otherwise, we can discuss in the day after tomorrow's class.